Hello everyone, Faith Reeves here. I'm going to show you how to take a soil sample. It's super simple, especially if you have a tool like this. This is a soil core, sample core. It's about 20 inches long, and we're going to take a couple of soil samples just so you can see how it's done and know why you might decide to do that. So why would you soil sample? One would be if you have a garden that is brand new and you're new to the soil, it's a good idea to know what is in your soil when it comes down to nutrients. And do you need to amend that soil? And another reason why you might take a soil sample is you've worked the soil in an area for a long time, you've been a farmer or a gardener in that space for a long time, and it's starting to underperform. And so you would like to do something about that. So taking a soil sample is basically just pulling a couple of cores, or actually 10 cores would be a great number of cores, from a similar soil type. And we're going to do it right here because we have 3 different soil types that we can choose from that I can show you the difference between. These beds on this side of the garden here, we're in our local community giving garden, and it's mid-May and we are getting this garden ready to plant. So that's what a soil core looks like. You're wanting about a 6-inch core. This is about 5 inches. We'll end up pulling another core to get a better sample there. But you can see that this soil, there's topsoil, where that dark carbon-rich soil right at the top, and then at about 4 inches down, it starts turning to clay. And so this bed was built on top of the existing soil here, and it was a clay layer. These beds have been here for about 15 years. They've been utilized not intensively over that time, and we've had topsoil created, but also topsoil was imported here. But it is a sand, silt, clay substrate at this point. We've got good organic matter, and we have a clay layer down below. In front of me here, we have another bed, more recently created, and this bed was filled with something that's so much more rich in organic matter. It was a compost. So not a lot of sand, silt, clay in this substrate, mostly an organic matter, carbon-rich substrate. So we have 2 distinct soil types here. This one is more of a sand, silt, clay substrate, the media, and then we also have a more organic rich soil here, very little sand, silt, clay. The soil right underneath my feet in the walkway would have been more, more similar. It is the native soil. It's had wood chip on it for quite some time. So we've got a high organic matter right at the top of the soil surface, and then we've got a lot of clay. Quite different. So over here we've got about 4 inches of topsoil, very carbon-rich material, a lot of organic matter, but it is more of a sand, silt, clay substrate. Here we have much more clay, thin layer of topsoil being produced, and high organic matter right at the surface, and here we have a lot of organic matter. Most of your labs are going to have you pull about 10 representative cores from your area, similar soil type, and they are either going to ask you to mix it or not mix it. Depends on the lab that you're using. So look at your lab's sampling information to see how they would like you to prep your soil sample. Here, we're going to take 10 representative cores. We're hitting a very compacted layer of clay there after you get below the that really organic rich topsoil. I don't like to step on a bed because these are raised beds. I don't want to compact the soil, but in order to get a good sample, I'm going to need to step on the bed. We want to do a random sampling across the area. Because I'm looking at 3 very similar soil types, I'm going to pull samples from each of these, maybe 3 of each, and call that a composite sample. Put it in a bucket. Put all 10 cores in your bucket. When you're sampling your field, if you have a in-place garden that is, say whether you're using raised beds, you know, that you've tilled or had soil disturbance, whether you have a, you know, no-till, compost over soil type of planting area, or if you're just, you know, working with a broad acre row crop type of scenario, you in essence want to look at your soil map, look what your soil types look like, and stay within a particular soil type. You can do a visual assessment, but you can also look at the web soil survey, the NRCS web soil survey, if you're looking at a larger area. And you're going to take 10 to 15 representative cores, zigzag across the property, taking those samples, put them in your bucket. Don't pick the best places. Don't go over here to the fence line where no soil disturbance has ever been performed, or, you know, if you have a field, no soil disturbance would have been performed there. So that's going to be a really out of context sample, because the weeds are allowed to grow there, the grasses are allowed to grow there. You have a lot more biological life usually in those fence rows. It's a great sample to take, but make just a fence row sample. If you are looking to figure out what's going on, you've got some poor areas, then take that as a representative sample. Just look at the poor areas. But if you're trying to do general soil amending, or you're looking for a general assessment of what is going on with your soil health, your soil nutrient content, then keep yourself in the general area. This bed actually has quite a bit more organic matter than I anticipated. I think this bed was built more recently. I'm going to take that one core out because I don't want to artificially influence that soil sample. If you take your core, it's good to pull your organic matter away from, say you have mulch, pull your organic matter away from the soil surface. If you can't do that easily right off the bat, then go ahead and just scrape it away right at the top. So that is the soil surface. Scrape that O horizon away so it doesn't influence your organic matter reading in your soil sample. And here I have a sample that's larger than 6 inches deep. Here in Iowa, southeast Iowa, take a 6-inch soil sample. That's pretty standard for most labs. 6 inches, the math works out pretty easily. 6 inches or a furrow slice is 2 million pounds of soil for a standard soil, sand, silt, clay-based soil. Not for compost, not for high organic matter soil, but that just helps with the math, makes it a little easier. So I know that my fingertip to thumb tip is right around 6 inches. So I'm pulling these cores a little long, but I'm only going to put in a 6-inch core. So after you take your 10 cores, I haven't taken my 10 cores here, but after you've taken your 10 cores, you've put it in your clean bucket. It's important that you're using a clean bucket. You don't want a bucket that you've been using for applying soil amendments or moving concrete, dry concrete in, or had rusty nails in, because you'll have artificial nutrient levels picked up. Extra iron, extra calcium, extra whatever. So make sure you get a clean bucket. It doesn't have to be pristine, but you want to make sure it's been rinsed out and there's no residual particulate in there. Blend your soil samples together. Don't take a soil sample when the soil is really moist, and don't take a soil sample when the soil is really dry. Try to find that happy medium if you're looking for a happy medium type of result. If you're trying to figure out what is going on with your soil, if you're sending your soil sample to the lab to get a biological assessment, you're going to have better luck if you've had living, growing green plants in that soil and the soil is evenly moist. You're going to get a better assessment of the biological activity. The biology is going to be up, active, not dormant. So that's good. But if you're just sending it away to the lab for a standard soil test and you're getting a nutrient assessment, it doesn't really matter so much if it's moist or dry. It's just easier to work with when it's not super moist and not super dry. You can get your core in the ground. Really important that you label your bag. You don't have to use a gallon bag. You're only going to send 2 cups of soil to the lab. They can run 3 or 4 tests off of 2 cups of soil. You want to check with whichever lab you're utilizing, but you can send 2 cups of soil in a standard bag like this, a Ziploc bag. If you're sending your sample to the lab to have a biological assessment done, then chill it first. You could take your sample right now in the evening and then put it in your freezer overnight. Yes, you're going to freeze those microbes, but you're really just going to chill them out and they'll go dormant. And then you can put them in your 2 to 3 day mailer, get it to the lab really quick if you're going for a biological assessment. Again, you want to make sure that you label very clearly. If you're going for a biological assessment, you may want to not seal it up completely until you're ready to get it in the mailer. What they're going to do if it's a biological assessment is they're going to rehydrate this soil and do a respiration test, perhaps maybe do a DNA test, depending on which lab you're sending it to. But preserve your biology if you need to by chilling it. If you're just sending it to the lab for a nutrient assessment and they are using a strong acid, don't worry about doing any of that extra stuff. Take your sample, label it well, make sure it makes sense to you. The label that you put on your bag, make sure that that makes sense to you. You know where it is distinctly, uniquely. Use that same label or that same ID, sample ID, for your submission sheet. Send it to the lab, and then they'll email you your results. Thanks.